few are having charges, few are not having charges. Let's call this capacitor. So we'll call charge Q1 minus Q1. This Q2 minus Q2. Let this be Q3 minus Q3. So initial charges first we'll calculate. Q1 should be equal to 2 into 3, 6 coulombs. Q2 should be equal to 5 into 4 capacitance into C into V. No? So 4 into 5, 20 coulombs. So Q3 is equal to 1 into 2, 2 coulombs. So Q4, 0 into 3, 0. No charge in that. After closing the switch, this will be the 2 farad. How to distribute the charges here? So just I'll assume like this, plus Q1 minus Q1 plus Q2 minus Q2. Here plus Q3 minus Q3 plus Q4 minus Q4. But sir, like you didn't bother like about anything polarities. If I get negative, I'll change the direction. I change the sign of that given plate. Let me assume there's a positive plate. If I get Q2 negative, I'll change the polarity of that. Then how many unknowns are there? Q1, Q2, Q3, Q4. Definitely we need around 4 equations. So first let me go for loop equation. So this should be the loop equation, Q1 by 4 minus Q2 by 2 minus Q4 by 3 minus Q3 by 1 equal to 0. This is one equation. We need few more. So I'll look at this particular plate. Charge of these two plates must be conserved, no? Because you see that they're connected by a wire. This charge of this plate cannot go here. The charge of these two plates must be conserved. So what was the earlier charge of this one? Plus Q1 plus Q2. Now, oh, symbols we have changed. Huh? I'll change the symbols. This should be 1. Okay, we'll go for at switch S1, at the junction S1. Okay, look at the junction S1. This S1 you look at. So charge of these two plates should be conserved. So from that, write down the equation. At S1, the charge, initial charge is Q1 plus Q2. Final charge, Q1 plus Q2. Okay, this one, here also some change will come. Plus Q2 by 4 minus Q1 by 2. This is at one value. So we know Q1 plus Q2 how much? 26. So this 26 equal to Q1 plus Q2. Similarly, at the switch S2. So what was the charge of the junction? Minus Q2 plus Q3. Minus Q2 plus Q3 should be equal to minus Q minus Q3. Now you can say that, sir, how come this was a positive charge plus Q3? You made negative. I too don't know. I'll solve it. If I get positive, what I assumed is right. If I get negative, then I'll change it. Then similarly, at S3, S3 is this one, no? Here this switch. Minus Q3 plus 0. Minus Q3 plus 0 equal to Q3 minus Q4. Q3 value how much? 2. So minus 2 is equal to minus Q2 plus Q3. Minus Q2 plus Q3. So this should be the 18 minus 18, or plus 18 should be equal to Q2 plus Q3. Last one more, at S4 we'll write it. S4 it was minus Q1 0 minus Q1 plus Q4. Q1 was 6, so this will be minus 6 equal to. So solving all this set of equations will get the required unknown. So how many different charges are there? Those many equations are needed. I think there's a one rule is what you have to follow here. Similar to like a registers here, the challenging for students is distribution of charge. You have to be very careful. Charge of isolated junction must be conserved. Charge of a cell must be conserved. These are just some basic rules which you have to follow it. Solving this will get the required answer. What about heat generated? Again, the same formula. The heat generated will be Ui plus work done by cell equal to UF plus H. Calculate initial and final potential. Check it. Here also heat will be generated. Okay, like this, if capacitors with not, we did only 1, 2 capacitor, no, a group of capacitors, I brought it here. Just see once, I will go for a few more cases.